Hey guys, my name is Austin Farr here with yet another math video for you tonight. Alright, and so again, Jordan, Mingo, and I worked together on this. So we both did it independently, came together, got the same work. So again, this is the work for finding the area enclosed by ellipse. Okay, so again, ellipse just looks like this. It's like basically a stretched out circle. I'm sure you guys know what the ellipse is. But a stretched out circle. And so we have our major axis, minor axis right here. Negative A to A, negative B to B up here. Okay? Just to have an idea of what an ellipse looks like. Okay. And this is our general equation of an ellipse right here. I'm going to draw a quick box around that so you guys know what I'm talking about. So this is our major equation for an ellipse. Okay? X squared over A squared plus Y squared and B squared is equal to 1. Okay? Keep that in mind for me. So then what I'm going to do next is I'm going to solve for Y squared. And solve for Y, that way I can get it into a format where I can put that into an integral. Okay? Because we're going to try to find the area. Whenever you're trying to find an area, you're always trying to use an integral to find an area underneath the function. Okay? Awesome. And now in our case, just so you have an idea, back to this picture of the ellipse here, we're finding the area of this one sector right here. Just this one sector. We'll multiply that by 4 because the ellipse is symmetrical, and so we can do that. Okay? Alright, so again, right here, all I have to do is solve for y. Solve for y, I got it right here. We've got that squared away. Now, like I said before, we're going to integrate that from 0 to a. Okay? We're integrating this. Now, to help us out with the integration here, I'm going to point your attention to this triangle we have here. So, basically what this triangle helps us to do is helps us to rewrite sine and cosine to substitute in for some of these variables we have over here, okay? Alright, so, now, I'd like you to pause this video and take a look at this triangle real quick. That way you can get an idea for how I did it. Okay, assuming that you looked at it first, let me explain it to you. So, what I did here is basically you do a squared plus b squared is c squared. Again, I did that right here, and I checked that to make sure that it actually comes out. You end up getting b, I think it's b to the fourth equals b to the fourth, r squared. But yeah, you end up getting, my point is that this ends up being true. And so once you've tested this using Pythagorean theorem, and you know that works, and you can use that to substitute for some values here. So I have right here, I have sine theta is equal to bx of a over b squared, again sine theta opposite over hypotenuse. And then I have x over here, I just solve for x, getting this. Then I have my dx right here, which I'm going to need later once you do my integral. Okay, and cosine as well right here, using the same thing, adjacent over hypotenuse. And then again, solving for b over here. Okay, guys. Now next what we're going to be doing is we're going to be plugging everything in for over there to replace what we have here. So again, we're replacing this chunk right here and this dx right here. Okay? Or we're replacing with, over here is going to be, we're replacing with b squared cosine theta and a over b squared cosine theta. And we're putting in a d theta since we're taking the derivative with respect to theta. Okay? So once we do this, we simplify this a little bit, get those b's canceled out. And then with ab cosine squared theta d theta. Okay? And then we take the AB out here, again, using a trig identity. Look in the back of your textbook, find the trig identities. And then you'll end up finding that 1 plus cosine 2 theta over 2 is equal to what we have, is equal to cosine squared theta right here. Okay? Alright, so then what I did next is I divvied up this portion of it, multiplied AB by that to get this. AB over 2, so it's again AB times 1/2 basically. And then AB times 1/2 times cosine 2 theta, right here. Okay? There's a d theta in there. Now, as I said before, we're doing just this quarter section of it right here. So we made our integral from 0 to pi over 2, and starting up here. But we're going from 0 to pi over 2, and a unit circle. Again, unit circle looks like this. And we're going from 0 right here, all the way to pi over 2 right here, which is this quarter, which corresponds with this quarter right here. Okay? Alright, so then once we did that, plugged in pi over 2 here. Alright, simplified that, did that. You can pause the video to look at my work if you want to go a bit slower. If you have any questions, post that in the description below. And then once we get that, we get 82 here, 80 over 2 times pi over 2 right there. And you get pi AB over 4 right there. Okay, and again, just to represent that again, we're only finding this quarter of the circle. Okay? So what we have to do lastly is multiply that quarter of the circle by 4. Okay, multiply that by 4. To get the equation for the area of the ellipse, okay? And so we end up getting A is equal to pi AB. And that is the equation for the area of an ellipse derived for you guys, alright? If you have any questions, comments, or concerns, please place them in the comment section below. Have a great night. Don't forget to be awesome. Awesome for our out.